SI units, Standard International Units, are based off of the metric system. In the metric system, we have mass has a base unit of grams, which is abbreviated with a G. Length has a base unit of meters, just like SI units, which is abbreviated M. And temperature is the same as SI units. It's Kelvin, abbreviated with a K. Time is measured in seconds, and that is abbreviated with an S. So you can see that in general, the metric system is basically exactly like the SI units, except that mass has a base unit of grams, not kilograms. So what is that, the relationship between kilograms versus grams? This is a way that we can take the base unit and make it either larger or smaller by adding a prefix to the base unit. So in this case, K stands for kilogram. The base unit is gram, the prefix is K for kilo. So there is a system of prefixes which make these basic units either larger or smaller depending on what prefix we use. Here's a full chart of all the prefixes used in the metric system. So if we start by looking at this point right here, this would be where the base unit is. So for instance, if I were measuring mass, this would be grams, abbreviated with a G, and there would be no prefix, no multiplier associated with that. So this would have a multiplier of 1. If I go in this direction, I multiply my unit by 10, 100, 1,000, so forth and so on. And so each of these prefixes multiplies the base unit by a certain amount. If I go in the other direction, so if we go down in this direction, we're making our base unit smaller because we're multiplying by a fraction. So if I multiply by a tenth, if I make my base unit 1/10 smaller, then I would put a D in front of it, and that would be decigrams. If I make my unit 10 times larger, then I would be putting a DA for deca in front of the G, and that would be decagrams. In general, the prefixes that we are going to use the most often are centi, milli, micro, nano, and then kilo, mega, and potentially giga. So those are the prefixes that you should know without thinking about them. To make this more concrete, let's see how adding a prefix changes the magnitude of my measurement. So let's say that I weigh 60 kilograms. So 60 kilograms, because K is associated with 1,000 times a gram, I could write this, I can just replace the K with 1,000, and I could write this as 60 times 1,000 grams, or 60,000 grams. So if I weigh 60 kilograms, that means I weigh 60,000 grams. If I want to go the other way around, so for instance, if I have measured my weight in grams and I've found that I weigh 60,000 grams, but I want to know how many kilograms that is, I could take these 3 zeros, because I know that 3 zeros is 1,000, those 3 zeros, and replace them with a K. So that is 60 kilograms. So it's very easy to do when we have all zeros and nice round numbers like this. But let's look at a slightly more difficult problem, perhaps, where we have measured, let's say that we've measured the length of a pencil, and we've found that it is 12.95 centimeters. And I want to know how many meters that is. A meter is related to a centimeter by taking the meter and multiplying by 0.01. So a centimeter is 1/100th of a meter. So if I take 0.01 meters, I have 1 centimeter. So that means that the centi can be replaced by 0.01. So I have 12.95 times 0.01 meters, because I replaced the centi with 0.01. And so if I take 12.95 and I multiply by 0.01, I will end up moving the decimal place to make this number smaller, because this is a fraction, and so I end up with 0.1295 meters. Another way to think about this that you may be more familiar with is that if you have 12.95 centimeters and you know that 0.01 meters is 1 centimeter, you can use this as a conversion factor. And so if I multiply this by 0.01 meters divided by 1 centimeter, then I have essentially just multiplied by 1. Because if this equation is true, then if I divide both sides by 1 centimeter, then this fraction is equal to 1. And so if I multiply anything by 1, I get the same thing back again. But what this does for me is to actually change the units. Because now this unit of centimeter, I can treat this as an algebraic quantity. I have a centimeter in the top here, and I have a centimeter in the bottom. And centimeters divided by centimeters divide out. And so these guys divide out, and then I'm left with 12.95 times 0.01 meters, and so my result is 0.1295 meters, just the same as we got when we thought about replacing the centi with what it means in terms of meters.